I accidentally learned a swear word in a foreign language one time. And I'm not going to tell you what it is because I've just started talking to you and I don't want the first thing that I say to be cursing. But just to give you an idea, it sounded like some random sounds that you would make when you stub your toe, like ow. Only it wasn't ow. But I was spending some time in that country teaching in an elementary school, and I whacked my shin on the desk and said, ow. Only I didn't say ow, I said this other word. And the students all gasped and laughed and pointed at me, and the host teacher asked me where on earth I had learned such a word. And I had to tell her I didn't even know, because it just popped into my head and right out my mouth. People are so good at recognizing patterns that we can pick them up and use them without even knowing that we're doing it. This talk is called Reading in a New Language. And like many of you, I recently learned a new language, Swift. My last project was one of the first to adopt Swift in a production code base, so I got a lot of experience with it very quickly. And working with this new language has been sometimes wonderful and sometimes not so wonderful. And it reminded me so much of my experience learning new human languages that I wanted to share with you some of my thoughts about fluency and code. We'll talk about what readable code even is, and then why you'd want to write it. And then once you're convinced that you should, we'll move on to how to write readable code. And once we've got a handle on how to do it, we'll talk about when it's worth actually exercising that skill. But first, I want you to believe me that programming really is a little like learning a new language. When you first do something in a new programming language, it works. Like something prints, you feel like a demigod. And similarly, after maybe a couple weeks of studying a new human language, you'll work up your courage and you'll ask your new classmate out maybe to some coffee. And you'll say to them, "You and me, today after class, coffee?" And maybe they answer like, "No, I'm sorry, I'm busy after class today." And then how do you feel? You feel amazing because you asked if they could meet after class. They said they're busy after class. That means they understood you. It worked. And to continue with this human language scenario, maybe after another few weeks of studying, you bravely ask a different classmate out to coffee, and they say yes. And then you spend 10 minutes over lattes talking about how is the weather today, describing your families. If you're feeling very confident with your past tense, maybe what did you do last weekend? And it is the most boring conversation in the history of conversations. But you leave the meeting feeling pretty good because you just understood each other for multiple sentences in a row. Yes. This is like with iOS code. You know, the first time you get some data to display in a table view, yeah, it's not very glamorous, but the first time you did it, you felt a little like a genius, yeah? Yeah. Back to human languages. Let's say that you've been studying for years and you're really fluent. And you ask someone out on a date now, you're not thinking about your grammar, you're thinking about whether your hair looks okay. And then on your way to the coffee shop, maybe you start arguing about movies and you discover that they don't like Kurosawa. What? How is this even possible? So even though you're understanding each other's words very clearly, you maybe pretend you got an emergency text message like, "Oh, I'm sorry, I have to," and then you cancel the date before either one of you wastes any more time. For code, maybe this is like interviewing a job candidate, and things are going really well until you discover how much they love to use and abuse KVO, and maybe you don't give them a chance to explain. You just "Thank you very much for your time." As we develop fluency in human and programming languages both, we leave the basics behind. We start focusing on this nuance and subtlety. So sometimes, even when we understand someone perfectly, the way they communicate their intention still sometimes makes us want to throw things. And that's usually a sign that you're holding onto a stereotype. For example, people in the US will say, "I don't think people from the South are stupid or lazy. I just think the Southern accent sounds stupid and lazy." Yeah, really? Have you ever held a belief about an accent that didn't match some stereotype or bias that's common to that group? And these sorts of stereotypes and biases carry over to programming languages and communities, too. For example, does adopting a functional style mean that you identify personally with the people who not only love single-letter type aliases, but also know a suspicious quantity of Taylor Swift lyrics? Like, I hate side effects as much as the next person, but I don't think We Are Never Ever Getting Back Together is a particularly good song. And can I even get excited about functional reactive programming if I don't also love single origin coffee? And factory patterns and builders, I think of this as a very Java thing, and I know very little about Java, so I'm about to tell you one of my stereotypes that I'm sure is untrue. But it feels like something people use if they write serious, heavy enterprise sort of software and like it. Now, I'm not ready to have kids and move to the suburbs, so even when I'm writing Swift, I feel funny using classes that are such and such factory. Computers, they execute code without complaining too much most of the time. It's the humans around the code that have all this baggage and all these biases and all these extracurricular requirements for our understanding of a program's source code. And most of us would say, without hesitation, we would love to spend our days working with clear, readable code. I think it's not uncommon, and not an uncommon feeling to say, you know what, I would rather have code that's broken but understandable than code that's incomprehensible but somehow mysteriously works. But what does readable code even mean? I want to lead in with a story. One time I witnessed a conversation between two devs over a code review. The first person said, "Could we change this pattern? I'm having trouble understanding it." To which the other replied, "No, see, it's more readable this way." Now, in English, you can describe something as readable or enjoyable without defining who is able to do the reading or the enjoying. If you ask, is LA an enjoyable city, you know the first question is going to be, it depends, for whom? And yet for reading, with this code is readable, this pattern is clear, we somehow imagine that this means something without specifying a reader. There are as many opinions about what makes readable code as there are coders. I want to illustrate readability, though, from another angle. I want to illustrate it with a part of a poem, a couple lines from When Serpents Bargain for the Right to Squirm by E.E. Cummings. When serpents bargain for the right to squirm, and the sun strikes to gain a living wage, when thorns regard their roses with alarm, and rainbows are insured against old age, then we'll believe in that incredible unanimal mankind, and not until. I'll read it again. When serpents bargain for the right to squirm, and the sun strikes to gain a living wage, when thorns regard their roses with alarm, and rainbows are insured against old age, then we'll believe in that incredible, unanimal mankind, and not until. Now, there is something delightfully unsettling here, right? There's a meaning that slips away until we read and reread and reread, and then something shifts and the pattern falls out, and it is so satisfying when it resolves. And when it does, we look back at the original text and wonder how we ever failed to grasp it. Now, it took me about 10 times reading this poem before I started to understand it, so if you're feeling a little bit puzzled, don't worry. I wish we had enough time that you could all read it 10 times, but you probably want to talk about code more than poetry. But although rereading a poem is wonderful and satisfying, I would argue that this kind of poetry, the kind that requires many careful readings to get that satisfying feeling of understanding a deeper beauty, has no place in production software. In production software, I want the sparse, immediate poetry of warning signs where the more important and urgent the message, the quicker it is to understand. But even though we nod at this, I promise you that we are each picturing a different implementation of what it looks like for code to be obviously clear. A part of this is because we each have different strengths and different contexts. It's easiest to see when you're first learning a new human language. Maybe a nurse in the US will pick up basic medical Spanish. A tourist shopping in Martinique may learn to negotiate a price in French. I went to Jaipur in India, and I realized I'd mostly practiced Hindi from Bollywood movies, so I could tell my taxi driver, "Teri aankhon mein ajab si adaye hain," which means there is a strange beauty in your eyes. But I couldn't say, "Stop the car, here is my hotel." And so while using a bind may really seem like the most efficient way to express a relationship, if your teammates haven't learned these concepts, it will obscure your intention. So you may say, sure, fine, not everybody knows everything, but you're a professional, figure it out. This attitude means that for some people, admitting that you're having trouble understanding someone's code is like admitting that you're having trouble doing your job. So if you see a class that you have to puzzle over before you understand what it's doing and why, it doesn't feel like a problem with the code, it feels like a problem with you, with your professionalism as a developer. It can feel like trying to read an article in a language that you've only been studying for a year or two. You struggle through slowly while your friend, who's been studying diligently for 10 years, skims through it quickly, points out a grammar mistake, smiles at a play on words. It's really clear that the difference in speed to understanding is related to your skill with the language. Now, some teams say they'll only hire people who are fully fluent. We don't hire interns, domain experts only. But for those of you trying to hire iOS devs, how many candidates do you get who can read and write Cocoa code at an expert level? And even if you find this person who surely exists, who knows all the syntax and all the libraries and has agreed to join your team, the other engineers on your project are busy writing new code, which is effectively adding new vocabulary words to the language all the time. So how can people possibly stay perfectly fluent in the vocabulary of a language that changes hour by hour? So you accept that you can't hire a perfectly fluent person, but you still come back and you say, well, a skilled engineer, they can figure it out. It doesn't matter the language. It doesn't matter the abstractions. We're hiring them because they'll ramp up. They'll learn. Yeah, this is true. It's similar to the way that a skilled linguist can decipher any passage given a dictionary and a grammar guide, just like when we as coders come across unfamiliar functions and concepts. We look them up one by one in the docs or in the source code. And yeah, that's part of the job. You put in the time and effort, and especially with good tools, you'll decipher the meaning. So yeah, we will figure it out. Have you thought about how this process works, though? How we are able to figure out and read new text? Now, it turns out there's a strong tie between reading and working memory. Working memory is this extremely short-term store of very limited size, like 5 to 7 things. It's the thing that lets you remember a phone number long enough to type it into the contact field in your phone and then never think of it again. Or when you're first learning to read, it lets you remember the letters that you decoded at the beginning of the word long enough to make it all the way to the end. Now, working memory holds on to stuff for about as long as you're using it, and as soon as your attention directs elsewhere, that information starts to decay. So let's say that you have 2 things in your head, but you have to go look up the 3rd and the 4th. You're going to start to forget 1 and 2 before you have any chance of getting to 5. But you read things that are longer than 5 or 7 items all the time. When you're a fluent reader, you can read a word in English or German that has a lot more than 7 letters, especially in German. How does that work? So we do this by a process that cognitive scientists call chunking. Now, chunking is when you take a bunch of primitive things, like letters, group them into a single thing, like a syllable or a word, and then you just have to remember the group as one thing, and that gives you some slots back. You're probably thinking this sounds an awful lot like abstraction, and you would be right. So that's how we understand meaning from text, whether it's language or code. You start with the pieces you understand, you build them up into more abstract pieces that you also understand, and eventually you really grasp the problem. But we are not talking today about the value of decipherable code. The only code that you truly can't decipher should be actual ciphers, code that is literally encrypted. Everything else we expect that we can eventually decipher. Deciphering and reading are not the same. Deciphering, this needing to stop and search in a reference guide every couple lines. You've done this, we've all done this. It takes huge amounts of energy. And most of us need special circumstances to be able to do it. We need quiet space and uninterrupted focus. We need reasonable blood sugar levels. We can't be too hungry. And I don't know about you, but as I get older, I need to have had a good night's sleep. Reading, though, reading happens when you can't stop yourself from understanding something. I hope that at least one of these would show up the way that I intended. Excellent. So, what colors are these written in? The part of your brain that reads wants to answer first, and it is wrong. So why should we want readable code? Because when you can read fluently, you can be lazily scanning through some code, and part of your brain sits up and says, hold the phone, that bit looks wrong. And then the kind of thinking, deciding part of your brain saunters over and says, oh yeah, that's not going to work asynchronously, we'd better handle that. Deciphering is exhausting, and you do not have the mental resources to decipher every class, every line of code. You want to offload as much as you can to the snap judgment part of your and your teammates' brains, the part that just knows that wir singten is not the past tense of wir singen. Paying close attention takes an enormous amount of energy, and energy is finite. There's an often cited study that tests subjects' willpower with fresh-baked chocolate cookies or biscuits and with radishes. Subjects are placed in a room with a bowl full of one of the treats and are asked not to eat them. After 15 minutes, they're asked to solve a difficult puzzle, a maze. Except, surprise, the maze is unsolvable. The subjects who only had to resist the urge to eat the radishes, they worked on the puzzle for 15 or 20 minutes before asking for help or calling it quits. The subjects who resisted eating the chocolate lasted maybe 8 minutes before they gave up, and they were grumpy when they did. So it's important to write code that your teammates can read, not just so they can solve problems with it, although that's nice, but so they don't drain all their energy doing so. So let's imagine that you believe me, that decipherable code is not enough, that we're really striving for readability, and we're thinking hard about our readers. But even then, it's hard to know what to do, right? You understand the code you wrote. How can you predict what's going to be easy or hard for a reader? Maybe even someone you haven't met. You're writing a public-facing API. You don't know these people. We can take a clue from our interactions with non-native speakers of our language. We're used to changing our speech when we're talking with people who are communicating in their second or third language. A lot of y'all have been doing it all conference. And we can learn a lot about these behaviors when we think about code, from these behaviors when we think about code. For example, you stop using so many idioms and slang. Instead of you rock my socks, what, meine Socke? Like, no, you are really great. For code, instead of in-joke sorts of names, release the hounds, what does that even mean? No, you choose names as straightforwardly as you can. Begin app setup network requests. Another example, you enunciate clearly. Did you know that in the US, if someone says, "Jichet?" they mean, did you eat yet? In code, enunciating clearly may mean you stop using abbreviations. You'll introduce regional dialects slowly. Y'all come back now. What, did I forget something? No. What they mean is, I hope you visit again. In code, you might decide to wait to introduce things like custom operators. I'm not saying never use them, but think about non-native speakers of your programming language and coders who have just recently moved to your code base. Now, my favorite technique for readable code, though, is using patterns. It's easier, it turns out, to group things together and chunk them when things that act the same look the same. Now, we can learn almost any pattern. English speakers learn plural rules for child to children and woman to women and sheep to sheep. And German speakers learn when to use ein Freund instead of einem Freund. You don't even think about it, you just do it right. We can all learn these really complex and seemingly arbitrary patterns if we have the chance. So help us by making your code patterns as obvious as you possibly can. To show a very small example in code, this code is simple. It's just setting up some variables. But even so, it's hard to scan effectively. The only difference between these variables, good idea description and description of bad idea, one's good, the other's bad, but you have to read the whole name in order to pick up on that. But look here, how your eyes pick up on the different shapes when the beginnings all line up. And this is also why people get excited about lining up the equals signs or the colons and method calls, because it highlights the differences and the similarities even more. You can use this pattern recognition not just at the line level, but also at the file and function level. Have you heard of the squint test? Squint is a wonderful word. It means to close your eyes almost completely, but not quite, so you're just looking straight out through your eyelashes to the point that the world becomes a little bit fuzzy. You literally can squint at code to try to see its structure without any of that pesky implementation getting in the way. Let's take a look. This is fuzzy on purpose. Don't worry if you can't see it. That's the point. But you can decide right away what parts look similar, which parts seem to be action, which parts are setting up. You might not even be able to tell what language this is, but you could make a guess about what you might pull out into its own separate function. So help us pattern match well. Just because we can learn to perceive a thing does not mean it's worth the mental overhead. Like, take your code that serves similar roles and make it look similar. This is going to help us develop our intuition, and our intuition is what will let us someday understand your code without drawing down our energy. Besides using patterns, the other really critical part to writing readable code is empathy. You believe in your heart that your code is perfectly clear, but someone just told you that they don't understand it. And we might respond by asking questions like this rhetorically, like, what's wrong with them? Why? We think they're not trying hard enough. We think they're not smart enough. Sometimes I catch myself thinking this at myself, which is both uncomfortable and unproductive. But instead, the empathetic, non-rhetorical way to ask is more like, what information are they missing that's making it hard to read this code? Now, this works both ways. Thinking about your teammates' backgrounds will help you write code that takes advantage of their particular experiences. And when you yourself are very confused in the middle of reading some new code, this question, what information am I missing? It helps you focus on what you need instead of how painful it is that you don't understand some code. So these are some guidelines for how to write readable code. But let's be honest, it is not always feasible to write code that's geared towards the least fluent team member. It turns out writing simple, clear code is really difficult. And when you're under a deadline, it can take more time than you have. Even if you don't have a deadline, sometimes it takes more skill than you have. It's hard. So our final question, when? When do you work hard to make something readable? And when is it okay to instead require your teammates to spend their energy to understand? The folks who landed the Mars rover have a coding guideline that I love. Code shouldn't be arguably, but obviously correct in the most important parts of your app. If you put code that your teammates can't easily read in the mission-critical parts of your app, it's like leaving piles of boxes and obstacles in a fire escape. Like, even if the fire escape is at an Olympic track and field gym and you know the athletes can get around the obstacles, we don't want them to have to when they're fleeing a fire. And because remember, readability requires a reader, mission-critical code needs to not just be obviously correct to you, the genius writer who wrote it, but to the majority of your team. There is no easy solution to writing code that everybody can understand. We don't even know how to eliminate misunderstandings between native speakers of the same language, speakers who have 10, 20, 50, 80 years of practice at communicating. Writing readable code is a hard problem, and that problem is not going away. But we can all use our pattern matching skills, our curiosity, our empathy to develop our fluency. So we spend less time deciphering and more time reading, so we have energy left over. So that we can write and build and create. Thank you.